So hello everyone. So over this webinar's topics will be of the Docker in the DevOps. So why Docker is very major tool in a DevOps practices that we are going to see in the today's webinar. So we'll understand deep about the Docker concepts. We'll see the introduction of it. We'll see the architecture of it, and we'll see the process and why this is used, why we should have to use it. That things we are going to see in a detail. So let's start now. So my name is Manthan Gadia and I am a DevOps engineer currently working on this kind of the DevOps tools. So I'm having that kind of the expertise working with these tools in a live environments, in a production environments. So that things I'm going to share with you. What will be the today's agenda? So in this today's webinar, we are going to understand containers are not VMs. So we'll see what is the containers and why it is different from the VMs. VMs means virtual machines. Then we will work with the Docker, how this can be built, can be shipped, and can be run on the various environments like Windows, Linux, and Mac. Why we should have to use the Docker. And then we will start with the Docker concepts, with the architecture of it, and then all the things. So let's start. So, do you know the following things like why we need Docker? What is the Docker? And then we'll see that hands-on of it, see the examples of the Docker. We'll see the Docker components of it. We'll see the Docker case studies. So we'll see the case studies, how the companies are adopting it and how they are using it in their current environments and how this is very helpful to the companies. So starting with the history of the Docker, as we said, Docker is a DevOps tool. So in a DevOps terminology, Docker is acting like a virtual machine, but it is not. It is a kind of the virtual machine, but it is not. So firstly, we will understand what is the Docker history, and then we will deep dive into the Docker's terminology, why this Docker is used, what is the key benefits, what is the architecture of it, and why we should have to use it. So starting with the 2002, Solaris have introduced the containerizations, and then zones terminology has been introduced. Solaris, okay, from the sun. So that is sun Solaris by they have introduced that container systems on a 2004. On a 2008, Linux containers had been introduced. So then how we can create a containers in a Linux OS, that has been introduced in a 2008. That version was LXC 1.0. So Docker starting point is 2004, where the container technology has been introduced. So containerizations has been introduced from the 2004. Then 2008, Linux has also adopted that things and have introduced in Linux. So how we can use it in Linux, that's been introduced in 2008. In 2013, Solomon Hykes starts Docker as an internal project with .cloud. So Solomon Hykes, the person who has started the Docker project. Earlier was the containerization project, but the specific Docker has been started from the 2013. And then When they started in a March, Docker's first version has been released on the open source. That was available to the all community. All of the people can use the Docker. That's been available in a March 2013. Then following Feb 2016, Docker introduced first commercial project. Okay, that is kind of the product has been created. So that Docker's first commercial product has been introduced in a market, and now it is called as a Docker Enterprise Editions. So they are providing the more features, more sustainable features that Docker's provides. So that is available with the Enterprise Edition software. In the today's open source communities having a 33 hundreds plus open community members who are working with that. There are 43,000 contributors who are helping to grow more and more and do the functionality enhancements on the Docker. There are 12,000 stars who are just using it and then forked it. Forked means they have pulled the source code of the Docker and then done the modification and release it. So they are helping the community to evolve the Docker more and more and then adding the features and functionality on it. So since today now, Docker is a very famous tool because of this terminologies and why this is used. The enterprise edition is also available and that is started from the 2016. So there are two versions available. One is Docker open source, which is a normal features having included. In the Docker enterprise editions, you will get a support. So the history of the server systems, okay, like if you want to run the any server system in your environments, what is the previous things which we are following since decades? So in the dark ages, one applications on one physical server. At that time, we are using one applications on a one server. If we want the another applications to be hosted, we are using the another system, another server. We will configure it, we will deploy the website on it, and then we will use it. So this is the earlier practice which we have did, and that was following at that time. So on that physical server, we are installing the operating system. On that operating system, we are installing the applications, and then it will be run. That will be one application is running on a one server itself. So this process was having some limitations on the application development side. What was the key stuck point there? That is like slow deployment times. So if I want to deploy any application's new version, I have done some changes on it and I want to deploy the new version. That was very time taking process because I have to download that source code, have to build it, have to generated artifact, I have to bundle it and have to transfer it to the server and then I have to extract there. Then my applications will be updated. So it will be a time consuming process and it will be the slow deployment times. Having the huge cost because one applications per one server, it is costing us more because we have to dedicatedly purchase the physical servers. If I want to deploy the another applications, I have to purchase a new server and I have to deploy on it. So it is also costing me for the physical servers price. Wasted resources. Because if the applications is not having the traffic, the resources which we have assigned through the physical server can be unutilized. And that is a waste of resources. So that was happening earlier before the Docker. Difficult to scale. If I want to scale my particular application, if my application is used by the many people, suddenly the spikes goes up. I cannot able to scale it. I cannot able to deliver it properly to the everyone and it will be crashing. Sometime it will be restarted, sometime it will be crashing, sometime it will be the very slow. That kind of the issues we'll be facing earlier before the Docker. So there are difficult to scale, difficult to migrate. If I went to just copy this application from here and just um, cloning it to the another server. Suppose this my server is required the maintenance. I want to keep that website live. So I will just deploy this source that these applications in another server. So I want to migrate it there. The data has to be migrated to the another server. So this migration was also very time taking and was very complex before the Docker. And also there is a vendor lock-in, because when we using the physical server, we try to buy the same server, same manufacturer server. So that is a vendor lock-in, because if I'm purchasing that one server which I'm able to configure, I will purchase the same server again, because that is easier to understand and easier to configure, because I already know about that. So that is a vendor lock, because that is a I'm keeping and purchasing it from the one vendor itself. That was the historical limitations. That limitations was before the Docker. So a history lesson has been taken. Now the hypervisor based virtualization has been came in a market. So at that time, once physical server was there, so on that we have started deploying the multiple operating systems. In a physical server, there is a one host operating systems like Windows, Linux, anyone. On that, we are installing the hypervisor. Hypervisor is acting to allow that resource allotment to the virtual machines. So I can create the more and more virtual machines. So each applications run in a virtual machine. So I'm running every applications in a virtual machine. So I can separate my applications to be run in a separate environment through the virtual machines, and I can use the one server only. So that is also saving me the cost, but I have to install the applications on that all three VMs. So three times I have to do the OS installation here. That is a hypervisor based virtualization. So this is the example of a VM. This is the house. On that there are multiple rooms. So that virtual machines is like that. There is one house like one server. On that there are multiple rooms. So there are multiple virtual machines inside that where our applications are running. Benefits of VMs. What is the benefits of here? Before the traditional system we are following earlier, or that time we are following the one server is equal to one applications. But here we are using one server is equal to many applications. So better resource pooling. So one physical machine divided into multiple virtual machines. So I can easily use it. Easier to scale. If I want to scale my applications memories and storage, I can scale it automatically, or I can just do it with few steps, so that resource allotment can be done very faster. VMs in the cloud. In a cloud like the Amazon that is providing the AWS, Microsoft providing the Microsoft Azure, and the VMware. VMware is providing you the tools to be installed in your system, and you can use the virtual machines. So VMs in the cloud, rapidly elasticity. So you can run the multiple virtual machines inside the cloud. So that cloud concept is also running in a virtual machine based. On that, you are just paying for that resource you are using. So that is a pay as you go model, which we are following in a cloud. So if I want any server, I will just go and request one server and I will get it. I will take the access of it and I can do my works. I can deploy my application on it and I can run it and it will be live. So that things we are following up in a VMs in the cloud. So we can rapidly create the servers with the help of the virtual machines, and that is a pay as you go model. So I'm paying for that, which I'm using. But there are some limitations of the VMs. So each VM still requires CPU allocations, storage, RAM, and entire guest operating system. As we have seen the example of the local system, on that I am installing the one applications. But before that, I am installing the hypervisor. So when I install the hypervisor, on above that, I am also installing the three uh, operating system, which is a different one that is called as a guest operating system. So inside that operating system, I'm installing the another three operating system, which is creating the resource to be utilized more. Because if you're installing three operating system, it will also consume the storage. That means each VM still requires the CPU allocations, storage, and RAM, and the entire guest operating system. So, which is a kind of we can say the waste, because we are reinstalling that. The more VMs you run, the more resource you need. So, if you are running the multiple VMs, you have the requirement of multiple resources like CPU, storage, and RAM. Guest OS means wasted of resources, because multiple time we are installing the same operating systems for our different environments, different applications. And the application portability was not guaranteed. Okay, so application portability is not guaranteed right now, because if you want to migrate your application from one server to another, that is not easy. Also in a VMs as well. So that is the limitations of the VM. So to resolve these limitations, container system has been arrived. In this container system, what happening? Standard packaging of the softwares and dependencies. So let's suppose I am a developer and I am doing the coding. Application is working fine in my system. But when I am sharing that code with another developer or another users, if they try to run, that is not working there. Because there are some software dependencies which is required to be installed in your system itself when you run. So this is a very time consuming. It is also providing the more errors when you are sharing the applications with anyone. They are saying like this is not working in my, but you are saying it is working in my system. So there is a conflict on there. So because of the conflict, this kind of the containerization has been started. On this technology, we are just standardizing our packaging for the softwares and dependencies. So we will just bundle that things which is required. Isolate the apps from each other. So this each and every applications will be isolated. They cannot are in a same kind of the things. They all are separated. That is isolated from each other and sharing the same OS kernel. So the OS they are using is the same, but the applications are different. So in the same OS resources, they are able to work. This kind of the technology has been introduced. It is called as a container system. So in this container, we are just installing one applications. In another container, we are application other applications. In a third container, we are installing the another applications. But that all applications are running in a one operating system. So now we are saving that operating system cost, operating system resources. So this is the shared same OS kernel. So that OS kernel is shared between them. Works with all major Linux and Windows servers. So this container systems are working with all the Linux and Windows servers. So this is containers are not VMs. That's why containers are not VM, because the terminology is being changed here. In a VMs, we are using the multiple operating systems, but in a containers, we are using the same base operating system. So the Docker containers are not VMs. Okay, that is a separate things. Docker is having the easy connection to make. So we can easily establish the connection with the Docker containers. Fundamentally, the architecture is different because we are following the different architecture. As we have seen in the previous slides, here we are following the containerization system. That architecture is different. But in an earlier one, we are following the another system like in a VM. So here we are following that guest operating system kind of things. But And as we have seen in Docker containers, we are just following the containerization systems. That is called as the container systems. That's why containers are not VMs. Fundamentally different benefits, because in the VMs we are saving the cost of the multiple hardwares, okay, but we are utilizing that resources. So we have to allocate more CPUs, more RAMs, more storage to our systems. But in a containers, we are also solving the problem of that resources, which we not have to allocate so much. So that is fundamentally different benefits of it. This is a container. So this buildings you are looking, this building is kind of act as a server. This is a one server, one building is equal to one server. On that, there are different sections, like there is a first floor, second floor, third floor, like that. On that all floors there are so many containers. Okay, so you just understand, like virtual machines are also working like that, but here in a containers we are using the same resources, like the we can say like the infrastructure we are using is the same. With the same infrastructure we are deploying the multiple applications. So in this one building, one server, multiple applications we are running as the containers. So this all these rooms are the all the floors having that rooms are called as the containers. So this is the example of it. So comparing containers and VMs, containers are app level construct, but VMs are an infrastructure level construct to turn one machine into many servers. So the comparison between containers and VMs. So if we see about the VMs, VM is kind of the infrastructure. We are installing it in a one server. On that one server, there is one operating system installed. On that, we are installing the hypervisor. So that hypervisor is installed. On that, we are installing the multiple operating systems. So that is are a separate virtual machines which are running. But in a Docker, like in a container systems, as we are taking the example of the Docker and we are learning the Docker, the containerization has following this host OS. So infrastructure is there. On that there is a base OS we have installed. On that we are installing the Docker tool. So the Docker tool is helping us to deploy the containers, the applications that is using the same OS environments. So we not have to dedicatedly run the operating system that is using the same resources. That is the major difference between the containers and VMs. Container is using that same operating systems for all that applications, but in a VM, separate operating systems are running, which is very resource utilizations happening because of this architecture. But in a containers, we are saving it. Containers and VMs together. So containers and VMs together provides the tremendous amount of flexibility for the IT to optimally deploy and manage the applications. So here, if I'm choosing and separating my environments using the virtualizations, I will deploy the one server. Okay, on that server, I will install the that infrastructure. On that, I will install the like that is a one virtual machine running on. On that virtual machine, I will install the operating system. On that, I am running the Docker. So I can create a separate environment for it, for the dev environment. So in a one virtual machines, I am using the Docker containers. In the another virtual machine, I am using the Docker container, so that I can divide that environments itself. I can separate it because virtual machines are separating their environments. So in a one virtual machines, I am creating a dev environment. In one virtual machine, I am creating a prod environment. So on that dev environment, I'm installing the Docker containers. Okay, so using the Docker tool, I can run the multiple apps there. Here also, in the other side, I can install the Docker container and the Docker tool will be installed, and then above that containers will be running. So I can use and I can take the advantage of the virtual machines with the containers. So in a virtual machines, I will deploy the Docker and run the many containers. So that is the IT's systems are using this kind of the approach to work in their environments with VMs and containers. Docker plus Windows servers, that is equal to Windows containers. So when we are using the Docker with the Windows servers, that is becomes a Windows containers. So here in architecture, there is an infrastructure which is a physical server. On that, we are installing the Windows Server 2016. That is example. You can install any of that. On that, I'm installing the Docker Engine tool, which is helping me to virtualize and create that Docker environment so that I can run the multiple containers in a different containers. I will run the multiple apps. So you can see here above the Docker engine, there are 3 apps running. That is a separate. So native Windows containers powered by the Docker engine. So Docker engine is providing this kind of support for a Windows containers. Windows kernels engineered with a new primitive support to containers. So Windows has allowed the support for the containers to be used with the Docker engine. Deep integrations with 2+ years of engineering collaborations in Docker engine and Windows Server. So Microsoft and Docker has worked 2+ years of this engineering and collaborations for the Docker engine to be run in the Windows Server. Microsoft is top 5 Docker open source project contributor. So Microsoft is helping and is above top 5 for the Docker open source project contributor and a Docker maintainer. So they are maintaining the Docker images. Key benefits of Docker containers. So why we should have to use that is starting from here. So if you're working as a system administrator or a cloud engineer or a DevOps engineer, Docker is required everywhere. So when you install the Docker, why we should have to use it? That things we are going to use. So we will see that speed. No OS to be boot is equal to applications online in a seconds. Because already we are running that one operating system, on that we are running the another applications, and that application is not required any operating system because that is taking it from the base OS which we have installed. So whenever you are using the virtual machines, you have to turn on that virtual machine. On that virtual machine, if any another operating system is there, you have to run it also. But here there is no operating system because this is the base operating system on that the Docker is running. So it will be launched in a seconds. The containers will be launched in a seconds. That's why no OS to be boot. So applications online in a seconds. Portability. So less dependencies between process layers and ability to move between infrastructures. So let's suppose I am running the Docker container in my system. If I want to share it with another one, I can easily share with them and they can download it and run without any issues because Docker architecture is same as in all operating systems. So if Docker is installed in my system, I am sharing that container with anyone, they can able to run it flawlessly because they not have to do any modifications. They have to just load it and they have to use it. Efficiency, less OS overhead. We not have to maintain the operating systems more because as we are maintaining the one OS that is done. But in a VMs, we have to maintain the all of the operating system patches, security patches, updates, feature updates, all. But here this is not having that headache. So this is a less OS overhead. And here is a improved VM density. Because this overhead is not there, that is very easy and easy to improve. The performance will be improved, the workflow will be improved with the containers. So the variables we have to consider in this Docker containers, so that will be the performance. We are getting the more performance. Security, because applications are not talking with each other, that is in an isolated environment, so that is a very secured. Scalability, so if I want to run the multiple Docker containers, I can run it, so I can easily scale up my applications. Existing skill set, if I want to uh, run any containers with prerequisite like the tools and dependencies, I not have to worry about it, that is already exist in that container, I just have to start it only. Cost, it is saving the cost, because as I'm working with the containers and I'm using the one machine only, on that one machine I'm using the virtual machines, on that above I'm using the containers, so I not have the worry about installing the multiple operating systems and purchasing the more hardwares, so it is saving my cost. So this is things we have to consider with the Docker. There are testing scenarios, like if we measure the testings of this topic, like with these three infrastructure, first one is virtual machines, second one is virtual machines with containers, and third is containers on bare metal, that is a bare metal storage, bare metal servers, which is dedicated for more performance. So scenario one is 8 VMs. Okay, in one virtual machines I am using the multiple 8 virtual machines. So here need to replace this graphics, the one W88 box. So this is the 8 box, first one. Second one is also having that 8 box. Third one also having the 8 box. So first scenario is 8 VMs. Second one is 1 VM with 8 containers. Third one is 8 containers on bare metals, where we are just installing the OS, and on that Docker engine has been installed, and on that we are running that server. Second scenario, we are using the one virtual machines. On that one guest operating system is there, which is above the hypervisor, and on that we are using the Docker container. So the results of this is moving from VMs to containers increase the performance 27 to 46%. In the scenario ones, if we are using the 8 virtual machines differently, we have to install the 8 OS on that virtual machines. One by one, we have to install the operating system on it. On the second scenario, we are just using the one server, on that one VM is there, on that we are running the 8 Docker containers. But in a third one, we are directly using the operating systems, on that we are using the bare metal, we are using the bare metal instances. So using that I can able to get more performance as comparison to the second one. So 46%, starting with 27 to 46%, I can jump in a performance. Additional savings, Docker allowed for savings in a memory and disk as well. So it is saving me the disk spaces, memory usages, and CPU utilizations. So you can see the scenario here. I can able to save more because the disk space is less utilized, because I'm running the container. I not have to install the OS multiple times. That's why it is raising the same operating system and it is saving my disk space. Also, I am not using the multiple OS, so that OS process is not required more. That's why it is not taking me the more memory uses. Third thing is CPU. If I'm running the multiple operating system, that CPU is required more. But if I'm using the one operating system, I have need the one OS related CPU utilizations. So that is also saving me in this kind of the resource utilizations. So this is the additional saving we are doing. Performance we are also getting, but we are also saving this kind of the resources so that we can also utilize this for another task. Key learnings of the Docker is we are running the Docker containers for increase the performance and flexibility. So the plan for the higher density, we are getting the more performance through the Docker. As the lowest resource utilization is there, we are increasing our productivity and we also saving the cost. Bigger VMs. So it can be runs on a bigger VMs also because at that time we can save more by running the multiple containers. Tune to optimize. We can optimize the performance of the applications because the low resources are used. We can allocate that for the application side so that users can be used for the application hosting. This is the process of build, ship, and run of the any app anywhere. So starting from the developers, this is the from dev to operations. So when we moving from development to the operations team, any app we are choosing here, like the first thing is anywhere. That means you can use Docker anywhere. So it can be on a physical machines like your server, your laptop, your desktops, your Windows server, Linux server, anywhere. On the virtual machines, on a virtual machines, you can also use like the VMwares uh, and lots of that. Citrix is there. Then cloud. So you can use it in a AWS cloud, Azure cloud, Google cloud, Alibaba cloud, any of the cloud. Like DigitalOcean is also providing the cloud. So at any of the cloud, you can use it. It can be worked on any OS like Windows or Linux. On that, we will top up to that. We are using the applications so that we will deploy the applications there. So by using these applications, we can deploy our containers throughout from the dev process to the operations. So this is the build, ship, and run. So if we are putting this all together, we are building the environment, we are shaping it through the images, and that will be deployed in our servers. That will be on our local premises or in a cloud servers. So let's understand the flow. First is the build process. When developers are doing the coding and the coding has been done and we want to release it, they will create a build. So that build having that artifact that is required to be deployed in a servers. So that artifact has to be shipped. How it is shipped? Through the images. So that will be through the create and store that images, which is called as a Docker images. So that image will be created, the layers will be created of it, the build process will be done, and after that it will be shipped, and that it will be run and deployed to the cloud or a local servers or your own local systems. So you can deploy it anywhere in your local system, on your servers, on your cloud. So this part will be the developers part. This will be the IT operation parts. So this is combined with the DevOps. So this DevOps process is very important for you. And for that, you have to use the Docker containers, which is resolving your issues for the build, ship, and run. There is some Docker vocabulary which we need to understand here. First is Docker images. So the basis of the Docker container is represents a full application. When we are creating any image that contains all the required things like dependencies, operating systems, and all, which is required to be run. So when we create any Docker image, on that all required things is present. and it represents a full application. So the full application is inside the Docker image. The Docker container is a standard unit in which the application service resides and executes. So that Docker containers will be act as a kind of the server. Okay, it will be kind of the application itself, but it will act as a normal server because it is isolated. So that Docker container is a standard unit in which the application service resides and executes. So that applications will be running in a Docker container with the minimal resources. Third is Docker engine. So Docker engine helps to create, ships and runs Docker containers deployable on a physical or a virtual machine, host locally or in a data center or a cloud service provider. So Docker engine is a tool which we require to install in our system. By installing this tool, we can able to run the Docker containers using the Docker images. So this is the dependencies. Docker engine is required to be installed. After that, we can run the Docker containers, but using images. So with the images, we can use the Docker containers in the Docker engine. So this Docker engine is a tool which is you required to be installed in your local machine or any virtual machine or on a cloud. Registry services. So registry service is a kind of a Docker hub or a Docker trusted registry. So this is the central locations, okay, where our images, this Docker images will be saved. So if we require any time, we can just pull it from there. We can download it from there. So we can do the upload and download on this registry. This is the centralized location where our Docker images are getting stored. So the cloud or server based storage or a distribution service for your images. So you can store it in a Docker hub, which is an online tool where you can store. So that this will be the online portal on that Docker hub is there where you can create an account and you can store your image. And Docker trusted registry. So there are some registries which is provided by the multiple cloud providers that you can use. Like AWS is providing is the ECR, Amazon that Amazon is providing, and then the Azure is providing like the container registry, Azure container registry. So that on that you can store your data. That will be the container images. So that container images you can store at that location and you can pull it out when you require. So this is the 5 terms which is very required: Docker images, 4 terms: Docker images, Docker containers, Docker engines, and registry that is called as a Docker hub. This is the basic Docker commands, okay, which will be required when you working with the Docker. So first one is Docker pull. So it will be required to pull out your images. Then images will be tested out. We can run any containers. We can check the containers. We can stop it. We can remove it. We can build it. We can push it. So this is the referencing commands. This is the basic command which we can run through the Docker process, which we will learn on this course. Docker file. So this is the example of a one Docker file. This is the Windows Docker file. On that you can see that is a Microsoft's Windows Server Core OS is used. On that we are installing the npm node version, that is the dependencies of the applications. On that we are running the PowerShell command to download the file, then rename it and then deploying it. So that applications we are doing deployed through the Docker container with this Docker file. So Docker file is having that instruction stored which we want to do with particular Docker container. Docker container architecture. This is the main highlight of the today's topic. So how this architecture is working. So there are image layers. As I told you, Docker is working with the images. So this image is having that all required dependencies. So on that image, that is one kernel which is using by the operating systems, base operating system, which is installed in the system. So the kernel is taking from there, but the rest of the libraries that is taking from the image itself. So you can define the install requirements, copy requirements, upgrade pip, or that is a Python operations, install Python and pip, and then there is a Alpine Linux. So you can run the any of the Linux to the Docker. If you want to create a script for it, that is called as a Docker file. The instruction file, you can create it from that as per your requirements. So this is the image layer. On that, these things are explained, how this fully functional Docker containers is working and what is the image layer. So there is a kernel there, then the Linux is there, then the Python is there, then upgrade commands is there, copy requirements is there, and then install the requirements is there. So doing all and performing this all tasks there, and then the container will be run. Some things about the Docker file systems. So there are logical file systems by grouping different file system primitive into the branches. So there are logical file system which is followed in the Docker. Like there are directories, file systems, subvolumes, and snapshots. This kind of the architecture is followed in a file system of the Docker. So logical file system by grouping different file system primitives into branches. So they have divided this in a branches like directories, file systems, subvolumes, and snapshots. Each branch represent a layer in a Docker image. So this each branch is seeing like this is the layer, that is a one layer. Allow images to be constructed, deconstructed as needed versus a huge monolithic image as ALA traditional virtual machines. So as we seen about the virtual machines, that virtual machines having also a kind of the architecture where whole operating system is running. That is called as a guest operating system. So one guest operating system is running there, which is bundled with the application code, and that is taking the more storage and more resources. That is called as the monolithic image. But here we are just using the kernel and the OS from the base, and this is the lightweight images which we are using with the Docker. So that Docker images allow to be constructed, deconstructed as needed. But the monolithic images are not that. That will take a time. But this Docker images works faster. When a container is started, a writable layers is added to the top of the file system. So when the container started, writable layers. So if you want to write anything, that layer is exist and it will be added on the top. If we are building any images, that will be added up at a top. If we doing any modification on the Docker file, that will be added on a top. Copy on a write. This is super efficient. So sub-second in instantiations times for a containers. So it will be worked in a seconds. When you're launching any container, it will be works in a seconds because new container take at least below to the 1 MB of the space when they are doing the copy process. So containers appears to be a copy of original images, but it is really just a link to the original shared images. So it will just create a copy of that particular image. When you are launching the containers, it will fetch that image and it will be started. So that is called as the container. That fetched image will be started. That is called as the container. But it is really just a link to the original shared image. So that is not copied, but that is a linked of it because that's why it is launching it in a 1 minute, in a 1 MB per second. So that is taking less than 1 MB of the space. If someone writes the changes to the file system, if someone tries to write the changes of the file system, a copy of the affected file directory is copied up. So when you create image layers, if you are marking that like you want to copy the things, that will be copied and that will be marked there. What about the data persistence? Because containers are having that images, but where our data will be stored. So volumes allow us, okay, volumes allow you to specify a directory in the container that exists outside of the Docker file system structure. So if you want to store your data, that you can store in a base machine. So the data which is container is using, and if that is mentioned there, the path you can define, and your data can be persist on that particular location, and it can be saved there. So can be used to share and persist data between the containers. So that data can be persist. If you want to be used and saved, you can save it. If you don't want, you can just unsave it. That persistent volume will help you to store your data permanently. But if you not choose, if you not choose that persistent data, your data will be gone after the termination of the container. Directory persist after the container is deleted. So directories are persist there after the container is deleted, unless you explicitly delete it. So when you deleting the container, their directories will be also there. So that data will be also present, but that you have to delete it manually. So when you delete any container, that data is stored there, you have to delete it. Can be created in a Docker file or a via CLI. So that data persistent you can create through the Docker file or via the command line by running the command itself. So both way you can try it. But why? Why we should have to use the Docker? Enterprise are looking to Docker for a critical transformation. So you can see here app modernizing. Okay, app modernizations is like 3 out of 4 top initiatives revolves around applications. So applications are adapting this kind of the approach because we are able to deploy the applications in a few seconds using the Docker. So app modernizing is using this kind of the tools of the Docker because that is a faster one. 44% is looking to adopt DevOps. So DevOps are using it more because this process is very relatable to the DevOps task, because the developer is doing the changes that has to be pushed to the servers. So Docker is a kind of the tool which is helping is and solving that problems. 80% Docker is central to cloud strategy. So when we are saying about the Docker images, that is fully stored in a cloud. So that 80% of the Dockers is centrally to the cloud strategy. So that is working very well with the cloud technologies. Because in a cloud, we are getting the instance ready. On that, we are just deploying the Docker and just running the applications. So it is a very easier for us. That's why the adaptation with the cloud of the Docker is very much higher. It is a 80%. So now Docker delivers speed, flexibility, and savings. Docker is delivering you the more speed, more portability, more control, and more agility. So it is providing you the power to be deployed faster. First one is agility, so that 30x more software releases. Because of the Docker process, that is a faster one. 30% more software releases are done. 30% more effectively you can release your softwares through the Docker. 65% reductions in a developer onboarding time. So when you work with the Docker, the reductions in the developer onboarding time, because developers was taking lots of time when the deployment was going on, they are free. But with the deployment of with through the Docker, it will be getting instantly, and they will get the issues more faster. And then developers is start working on it. So developers are not free, and the reductions in developers onboarding time. So they will get faster these things done. Portability. So 41% move workloads across private and public clouds. So the movement of deploying the applications to the public cloud has been increased because of this portability. Because we are pushing that images to the Docker hub and related Docker container registries. So that container registries are more, which is offered by the public cloud. So they are also helping for the portability of the Docker images, which is helping to move faster and more faster and far and away for the deployment of the images on the cloud. Eliminate works on my machine issues. So as I told you earlier was that like this application is working in my system, but it is not working in your system. So that things has been eliminated because Docker is providing the same environment as it is running on yours and it is running on your other systems. So there is no issue of any dependency because we are already bundled it and we are sharing the container image directly to them and they are running that container. So there is no worries about installing the dependency that is already pre-installed. Control, so 62% reports reductions in a MTTR. So the control has been increased. MTTR having that report reductions is 62%. Cost reductions in maintaining existing applications. So as we using the containers itself, the existing applications cost reductions has been maintained by the 10x. So we not have to allocate the more resources for maintaining the servers applications that can be handled through the Dockers. That's why we have saving the cost on that. One platform delivers one journey for all applications. So the containerized legacy applications are like lift and shift for the portability and efficiency. So this is works like the one platform because Docker engine is same everywhere. That's why when you bundle any application, that will work at any portal, any location. It will be work like in a Linux, any Windows, and any systems where you are running the Docker. So this is the containerized legacy applications. You can containerize your applications and you can lift and shift. So you can just lift it up and shift to the various registries. Transform legacy to microservices. Earlier days, monolithic code was there. Now the microservices is introduced in the markets where there is not a single application. They have divided application in a multiple services. That is called as a microservices. So microservices are easier with the Docker because if we follow with the monolithic one, we have to deploy each and every application in a separate environment. But when we working with the Docker, we can create the multiple Docker images, we can create a multiple Docker containers, and then applications will be working fine. So we are transform the legacy to microservices through the Docker. Third one is accelerate new applications. So that is a greenfield innovations. So accelerated the new application. We can deploy more and more new applications in the same architecture because this is the isolated environment and that is using the same OS. So this is very faster for the accelerations of the new application deployments and like development and the deployments process. So this is the very faster processing we can do through the Docker. If we're getting started now, Docker's on the Linux. So if I want to install the Docker in a Linux, this is the commands to download that script and you can use it. So if you want to download the stable version, you can just go to the get.docker.com and you can just download the tools from there. And you can just run these commands and it will be working fine. So if you want to test it and experiment the builds, you can use this both URL there and you can try it out. If you want to run it in a Windows and Mac, this is currently in a beta version, but it is now available to all. Easy to install, so get up and running on a Dockers in a minutes. So you can within a minutes you can just install the Docker and you can run your application. Leverage is Hyper-V, which is used for a Windows, and XHVY, which is a Mac. So for a virtual machine, that Hyper-V is used in a Windows-based OS, Hyper-V is used, and for a Mac, that is a XHVY. Docker for Windows required Windows Pro 10, Enterprise, or Education. So if you want to run the Docker on the Windows environment, you have to at least install the Windows Pro, Enterprise, or a Education version. Full API/CLI compatibility. So it is providing the full capability and compatibility with that APIs and CLIs. You can install it through that. You can do the OS integrations for increased speed, stability, and the speed of in the Windows and a Mac. Docker for Azure and AWS. If you want to run it, you can directly run it on your virtual machines, which is running on a AWS or a Azure. So you can download that software from the beta.docker hub. So that is docker.com URL where you can just go to the docker.com and just download the tool. You can install it in your Linux machine, on your Windows machine, and you can start it. So in a Linux, you can just download the Docker 1.12, scale up and down easily through the Docker containers on the cloud, integrate with underlying platforms like the load balancer. You can integrate your Docker containers with your load balancer itself. So that is walk, jog, and run. First, we are doing the setup. So we'll set up your preferred Docker environments. Then we'll fire up some pre-built images like Nginx, Hello World, and then my Manthan/catweb. So you can just create the pre-built images. You can create the images there. Jog means pick a well-documented solutions like the WordPress or a Jenkins, like the tool you want to install. Build it yourself. So you will just build it, run it, like extend your walk solutions or a Dockerize an existing project, so that you can do it from the walk, jog, and run. Build your own Docker file, so you can create a Docker file using these solutions. Experiment with the Docker Compose and a Swarm mode. So that is a Docker's Compose, which is fully scripted version, where you just writing the scripts what you want with the Docker images, and that you can just mention in a script like Docker Compose and Docker Swarm. That's it for the Docker with the DevOps. So if you want to join the course, just opt in for the course with the eVision and start learning with the Docker, because Docker is a very important tool in the DevOps practices. This will resolve your 70 to 80% works of the day-to-day task with the automated way. So you can just bundle your application deployment from the previous process to this modern process. You can shift from the monolithic to the microservices designing, where you can just deploy your applications in a minutes. And this will also save your hardware resources and then the software resources like installing the operating systems, headache of maintaining it, and all the things. So you can opt in for your course through the eVision. You will get the guidance throughout the course. You can learn all the things with the eVision. You can ask the questions whenever required during the classes so that you will be get answered for that things. So if you have any doubt, you can ask it through the portal link and that will be answered. Thank you all of you. Have a great day.